Hello everyone, welcome back to my channel. So in this video we are going to learn about convolution by differentiation. Convolution by differentiation. Okay, so the convolution concept using differentiation. If you are first time to my channel, please consider subscribing and encourage me to do more videos like this. So normally convolution between any two signals, suppose x1 of t and x2 of t, I am taking two signals x1 of t and x2 of t, is given by minus infinity to infinity. So x1 of tau into x2 of t minus tau d tau. Okay, for any two signals this is the convolution formula. Suppose if you have taken differentiation d by dt of x1 of t convolved with x2 of t, so this can be written as x1 of t convolved with d by dt of x2 of t. Okay, so d by dt of x2 of t, right? Okay, so this is again from the property of convolution. So I have explained you about the properties of convolution. There x power n of t convolved with h power n of t is equal to y power m plus n of t, where x power m of t. So where m and n are order of differentiation. So I am differentiating the output. Okay, so differentiating output by one time, that is m plus n is equal to 1. Suppose m is equal to 0 and n is equal to 1. So that means you have to write x of t as it is. When m is equal to 0, no differentiation is done. When no differentiation is done, then you have to write x of t as it is convolved with n is equal to 1. So you are differentiating one time. So you have writing. So I am writing d by dt of h of t is equal to m plus n value is also 1. So it will be d by dt of y of t. So d by dt of y of t, which is the resultant of convolution between these two. So if you take the differentiation, of convolution between two signals, you can write it as x1 of t convolved with d by dt of x2 of t, or you can also write it as d by dt of x1 of t convolved with x2 of t. Okay, so both are same using this property of convolution. Okay, so this is the application of this property, right? So d by dt of this can be written like this, right? So I'll take this into consideration. So what can we write? D by dt of x1 of t convolved with x2 of t is equal to x1 of t convolved with d by dt of x2 of t. Okay, so what will be the convolution then? x1 of t convolved with x2 of t. So this differentiation, if you take that side, it will become integration. So minus infinity to t x1 of t convolved with d by dt of x2 of t dt. Okay, so this is the formula where you can find the convolution by finding the differentiation of any one of the signal. Okay, so this is the concept here. Convolution by differentiation means you can find the convolution of two signals by taking the differentiation of one of the signals, so that convolution can be solved easily. Okay, so this concept is used to find the convolution of some graphical convolution only, but for solving easily we are taking the differentiation of one of the signals, and this is the concept, and this is how we are going to solve. Okay, so let me take one more slide. I'll explain a simple problem on this concept. Okay, so next, if you are given with two signals like this, okay, and you are asked to find the convolution between these two signals. Okay, so you can use graphical convolution method also, right, to perform the convolution between these two. Okay, so but now I am taking the concept of convolution by differentiation. So in order to perform convolution by differentiation, d by dt of x2 of t is required, because what is convolution between two signals formula? x1 of t convolved with x2 of t is equal to integral minus infinity to t, that is common area under x1 of t convolved with d by dt of x2 of t dt. Okay, so this is what we have seen. So first of all we need d by dt of x2 of t, that is differentiation of x2 of t. So this is your x2 of t, so I need differentiation, so d by dt of x2 of t. Okay, so this is an unit step signal, so we know that it is an unit step signal. So at instant 2 it is rising unit, and at 3 it is decreasing, that is falling unit step. Okay, so what is differentiation of unit step? So we know that differentiation of unit step signal is an impulse signal. Okay, so this is the relationship between unit step signal and impulse signal. So rising edge of u of t represents positive impulse, and falling edge of u of t represents negative impulse. Okay, so that is, there is an impulse function at 2 because it is the rising edge. Okay, so rising edge of u of t so represents a positive impulse. So it's differentiation, I am talking about differentiation. Its differentiation represents an impulse, but it is an positive impulse, and falling edge represents a negative impulse, that is there is a negative impulse at 3. So both amplitudes are 1 and -1 respectively. This is your d by dt of x of t. Now this is multiplied or convolved with this one. Okay, so anything del of t convolved with x of t is equal to x of t. This is the property of impulse we have seen. So that means if you draw the signal x1 of t convolved with x2 of t, sorry, d by dt of x2 of t, so how will be the signal? So there is an impulse at 2, so it starts from 2, so instead of 0, now this signal starts from 2 because impulse is at 2. So x of t is starting at 2 and ending at 3. Okay, because the time period is still 1, so here also the time period should be 1. Okay, so this del of t multiplied by this x of t, I am taking it as x1 of t. So del of t multiplied by this x of t is equal to x of t at that instant. At that instant means at 2. Right. At 3 there is a negative impulse. When there is negative impulse, this is also, so when there is a negative impulse, this also get multiplied by minus. Okay, so this is also get multiplied by minus. So you'll get a negative step. Okay, with the same amplitude but in negative region. So this will be -2 and this will be +2. So this is from 4. This is your x of t multiplied by or convolved with d by dt of x2 of t. Understood? So when impulse function is multiplied by the function, you'll get the same function at that impulse. So now the impulse starts from 2. So it starts from 2, that means it ends at 3. So that is why there is an step signal which starts at 2 and ends at 3 with same amplitude, which is equal to 2 here. So I have written 2 here. And at 3 there is negative impulse, so this also will be shifted to negative side. So the same shifted to negative side with time period, same time period, which is equal to 1 with the time period of 1. But now it starts from 3, so it starts from the 0 plus 3 and 1 plus 3. 1 plus 3 is 4. So now it extends from 3 to 4 with the negative impulse is there, so we'll get a negative step. Understood? So this is this. And then what is the convolution formula? integration of this. So we know that integration of step signal u of t dt is an ramp signal. Okay, so positive unit step results in positive slope ramp. That is, ramp is in positive direction, and negative unit step represents negative slope ramp. Okay, so how will be the convolution? So convolution formula, so x1 of t convolved with x2 of t. By using this equation, I am drawing this now. So there is a positive unit step, so positive unit step from 2 to 3. So there is a ramp signal which starts at 2 and end at 3. There is a positive ramp signal which starts at 2 and end at 3 with a slope is equal to 2. Okay, so with the same slope, okay, d by dt of this, right? And then there is a negative unit step at 3 and ends at 4 with a opposite slope. So slope will be opposite to each other. So if this slope is some x, then this slope will also be x only. Okay, so whatever the rise here, there will be a fall here. Okay, because slopes are same, so at 4 it becomes 0. Okay, so this is the final output of convolution. Okay, so this is how we can find the convolution between two signals, okay, using the method of differentiation. Okay.